Hey, welcome back. Today I'm going to be continuing to work on Kano script. Okay, so since the last video, last stream, I implemented this. So just print int.kano, right? So um basically now we can print integers, right? So if I don't really have a good way to run it right now, so I kinda have to do this, right? But we can assemble it. Well actually I have to go to here and compile it first, print int.kano, and that's gonna create the TASM file, right? And this is what it looks like this, and then we can assemble it, right? Chasm, thinking chasm, and then same thing with this, and and there we go. Prints out 1, 2, 3, 4, 5. Yeah. So that's basically how it works. It's a little hacky right now because of how it has to be. Basically, pass a number, and then if the number is greater than 9, then we have to call it recursively, dividing by 10, all that stuff. And then we allocate a string, which looks like this. So we need two characters because we need one for the null termination so it can properly print, and then one for why does it need that? Does it need that? Actually, no, I'm thinking it might not. But then one for the actual digit, right? And then we do this thing, which is going to get the digit essentially. We do the plus 48, which is basically just doing plus 0. That might work actually, but I'm gonna do this. And then we set the first character of the string to be that. Yeah. So it works with any digits up to I don't know how many we support, but so you could do like this, print int 1, and that would print 1, right? So I kind of have to do this whole thing again. So actually I'm going to copy and paste it into there, and then I can do this a bit better. So actually, here, let me remove this bit. So I got to remove some stuff. Print int Adam, print int 10. Oh yeah, I just don't want those. I want the Kano file there, so you can actually look at it as like an example. Okay, but let's see. I can modify this run.sh here and use in, and that will actually execute it. So if I do that, I run it, then it prints out 1, right? And we can change it to whatever. So if you want to print out 420, you can do that, right? There we go. We could also print a new line if we wanted to. Just like write a line like that. Yeah, then it prints a new line as well. Yeah, so it is a little bit hacky, and actually I want to see if it works without this. Yeah, it doesn't. So it overreads. I don't know why, because it should be printing out the size. Oh, shoot, but it can't. It should be able to get the size. I'll make that a space. Yeah, but anyways. Okay, we just can't set it to the null termination character. Yeah, okay. So here's what happens. The way we get the size is we use Sterling, right? But when we overwrite the null termination character, then it cannot get the Sterling properly. So if we use any other character here. Okay, yeah. So that actually makes it even simpler. Yeah, it's still not great. I'd like to be able to allocate a string, like without actually doing spaces like this. Oh, but that does work. That works, and that's pretty cool. Oh yeah, but then basically just calls it recursively, you know. So we go here, and then the n divided by 10. So if we have 40, you know, then it would call that with 4, and then we print out this, and it would be 0. We print out the 4 first, and then the 0. Something you might notice though is this is supposed to return an integer, and we don't return anything. Okay, we can return something here, but then it breaks it, right? So I can show what happens basically. So we do that, and it prints out 442. And it does that because this kind of messes up the stack. When we call it here, we don't actually clean up the stack afterward, so it pushes that 0 onto the stack. So that's a problem. But also, it'd be nice if that could be void. So those are two things. So I think I'm going to actually leave this in for now, and I want to do that. So basically, when we call these, I want it to pop out the stack if it's not as an expression essentially. Yeah, because that sort of messes up the stack. So let's try doing that first, and then I'll implement void, and then I'm gonna look into like pointers and allocation and stuff, and see how that could look. So a few different things today. Okay, so it's really just in the back end, and it's just type what is it? Oh, right here. So basically, if we're doing this, if we're calling the function call like this, that means it's not an expression, so we don't use the value. So we can just drop the value, you know? So right now we can really just drop it. Wait, what? So we do this. Yeah, we get rid of the number of args, but then we also want the return value. So we'll need a way to check the return type once we implement void, because if there's void, then we're not going to return anything, obviously. But for now, we can just do stack size minus stack size minus minus, and this is for the return value to drop the return value. And I think we need to actually pop it off though, don't we? Do we need to? We might not need to actually. So let me run this. Let me compile that. That could be it. 400. Okay, that's that is not right. Okay. Let's see. I gotta think about it a little. So let's do not native, but type function call. Minus equals 2. What is it? I just want to see what that does, right? Let's build and run it. Yeah, then we do that. So that doesn't work, obviously. I feel like we need to actually gen a pop though. Like pop it. So can I do that? Gen pop 5. State at 5. Because that will do the same size minus 1 as well. Yeah, then it does that. Wait, why does it do that? That's interesting. Okay. It'd be nice to look at the stack. It's kind of messy in here right now. Let's see. We have 420. Let me do just 2 digits because that might be easier to reason about, right? So 4. So just print out the first digit twice. We change this to return 5 actually. Change this back. Does it print out the 5? It does not. Okay, so it prints out, yeah, it prints out the first digit twice, and then this one, it's gonna print that out twice, right? So if I do that, it would print, yeah, okay. So we have like the extra digit on there when we do the return, the early return. Okay, that is interesting. If we get rid of it, it works fine actually, like that. But we get a stack under. Oh yeah, because we gen the pop. That's why we get a stack underflow. But yeah, you can see then it will generate properly. But it really shouldn't do that. So let's see. So let's look at the generate assembly. And let's look at, so we call this, and that's gonna have that extra thing on the stack because we get to the return, which, oh shoot, no, where's the return? And oh, we just have the end. Yeah, we don't have the return right now. Yeah, let me put it back. Return 0. I want to sort of simulate what's going on. Okay? We can look at it. So we have return here. Here's return. So we push 0. How do we push 0? Oh yeah, that's the value we're returning, obviously. Okay, and we end swap with 2. So 0, 1, 2. So I'm assuming that's going to be for the at the top of the stack, right? We can pop off the other 2 things there. And if we had 1 extra pop, then I believe it works. If I do this and build it. Yeah, then it will, then it works properly. So that's the thing. We have like one improper thing. So if we go up to, oh, I got rid of one. Yeah, but you see, we generate the correct number of pops here. But when we call it here, call this, we want to pop afterward. Yeah, if we generate the pop there, then it works. Because we had that value at the top of the stack, and we want to get rid of it when we just call it like that, since we're not using it for an expression. So, why can we not gen the pop like this? What is that? Because I should put the pop right there, so let me run that. It did not generate that. Oh shit, I didn't rebuild it. Okay, so why did it not work? Because we had the pop here now. But now the stack size is different, so it just reaccounts for that. Okay. Actually might be a bit more complicated than I thought. Right, so let me look actually at the type return. So we have return scope n. Why does it have to be different? We just make the scope n. Then I might actually get a stack underflow. Stack underflow in a different place. Hang on. What the heck? I mean, it did work. Did work. don't know why we get a stack underflow. That is interesting. But that's not what we want. We have the return scope in. I don't remember exactly why I did that, and I should have kept that. Pose is too great. That's a good message. Okay. Position. We set it to that. Okay. Oops, I didn't mean to exit there. So, right. What if we call it twice? Then do we get, sort of like double the problem? Triple N reference for assignment? Why is that? Let me read it. Yeah, why do we get that? And also, why is it this? There you go. Reference. What's reference? Yeah, why is it not, why is it like zeroed out, you know? Okay, that's not good. So why does it call it twice, you know? What I'm saying. It is interesting. So, yeah, there's a bit of problems. Let me try to implement void, and then I'll come back to this. Yeah, void. So we can do that. I basically just a new type, which expects nothing. So we don't want any return. So what we'll have to do is, if we, like, I'd like to have return with no expression afterward. But I'm not going to implement that yet. So instead it's just going to be, you know, it ends, right? Get to the end, and that's what we'll expect. There's going to be no expression. And if you put a return in there, then, we'll just, like, we'll throw an error, right? Because you're returning from a void function. Maybe in the future there'll just be a warning, but for now it's just going to be an error and it won't compile. That is the plan. Okay, what it is now, it's like, let's do that one. But why does it not complain about void? Like it shouldn't like that one. Yeah, it should complain about that, but it's not. So that's not exactly good. Let's add void though. Void, and the length is 4. Okay, so we have that. We need to add the token type void, so I'm gonna put it after integer, I suppose. And we need to add it in here. So token type integer. I am missing char literal. Type of void. Hang on. We don't have char. Actually goes before this. Char. Okay. Okay. So we have that, and then we need to. Do we have this? Handle data type. Type. Okay. Data type size. So that's this actually. Okay, so we're good with that. So that should be it for that. And then it should be considered a type already, I believe. So we need to go to backend.c and add this here. So it's gonna be 0, right? Because there's no like sides of void. What happens if you do sides of void actually? Like in C, you know? Yeah. So vim size. Size. I just want to size of void. Like, is it gonna throw an error or what's it gonna do? I need H. Yeah, I don't know what happens or what's supposed to happen. It's 1. Okay, that's interesting. Is it? If I do this, is there? Okay, so in pedantic it says that. Okay, it still does compile, but yeah. So I would just set it to 1 because I guess that is, you know, yeah, 1 is fine. Okay. Yeah, even though it's not like valid, it's not really a valid thing. And then sets the data type size. I don't think that matters too much, but basically, what we need to do is it will set the data type, and then the function should have a return type. Do we set that? We better set that as a function. Hey, let's see. I think it's in depths. Function. The function type. So I assume that's the return type, right? Let's add type void. Alright, so there we go. So if the function type is a void, then we're gonna have an issue, right? So we need to keep track of that on a stack of sorts, right? Or hang on, what do we get in the type return? We have this. Do we have a function on the top of the stack though? Because we have the scope stack, but we don't have anything on the function stack, do we? So here's the function declaration. We append it to the number of functions. Can't really grab the current. Well, we could do this, right? So if we actually just look at the type of the function on the top of the stack, that's gonna be the current function that we're in. So we could even use that. So let's just do if state functions dot, whoops, that is not how you spell that out. Functions dot count equals 0 and print error. Let's see. Return without definition. Because you can't return outside of a function, right? So print that error. We need the location as well, so we can choose the no location like that. Okay, and then we're safe. We know that we're safe to then check the top of the function stack. So state functions. So this could even be moved up here because I think it makes sense to go at the top of the return. And we're not generating any code or anything. If state functions dot data, state functions dot count -1, we have to do the -1. Yeah, and it's always going to be greater than 0, so we're good. That type equals type void. That's not what it is. It's what is it actually? So it's in the defs. We can look at that. It is type void. Okay, that's actually confusing. So I need to fix that. But yeah, we have some other things, but it's the wrong one. Type void. Yeah, equals type void. Then we're going to print an error as well. So node lock. Let's see, function. I think we can get the function name as well. Function that. Let's do that. Type of void. Return that. So again, as I said, in the future, we're gonna have it where we can return without an expression, right? In a void function, and that would be valid. But for now, if there's ever a return, it has to have an expression currently. So we have this issue, right? So then we can do state functions. Let's actually set the function. With state functions dot data state functions dot count -1. Then we can do function dot type. Stuff like that. Function dot type, and here it's going to be function dot name. Okay, let's see. Does this compile? Almost. TT void not handled. Alright, that's fine. And then this is an issue. Alright, so that's a string view. So we can't use that. We need to use view print and use view arg, right? Arg. Feeling like a pirate right now. Okay. Wait, then it. Okay. Okay, yeah. TT void not handle switch. That's fine. So that's in the front end C, right? Type. Just look at that. It's not this one. It is down here. Yeah. So case open type void. There we go. And now it should compile. Go here, and you can run it. Okay, so let's try to add a return here. So just return 0, and it should give us an error. From your print int. Alright, I don't really like that error message though. Right, whoops. Uh-oh, that broke something. Void. Yeah. So function with void return. Returns value. That might be better. I don't know. Error messages are hard. Like it seems like it's easy, but it's really not. Function with void return type print int returns value. Right, okay, hear me out. Let's put this before that. avoid return value. Okay, I think that would be good. Like, doesn't really matter. I'm really probably gonna be the only person that actually uses this language, at least for anything more, at least slightly complex. So, it doesn't matter too much. But yeah, function print int, return type void, return type. Okay. Mm. So also, I'd like to check if it has a return type, that it does return a value. But how would we do that? You know, how can I detect that? Like, we could have a counter for the number of returns stored in the function, and we iterate that when we actually encounter a return, you know? Yeah, then that works. And if we don't have a return, it's not going to say anything. We still get a stack underflow, so why do we get that? That is not very good. It's in the actual, the bytecode, right? That is underflowing. Why is that? What did I actually change that caused that? Hang on. Is this something I did here? Let's see where it could be at. So it's after we write everything. What is it? Is it this? Okay, so it's before that. Oh shoot, no, we overwrote it all. Hang on. Let's see. Is it this pot, perhaps, that is causing it? I don't think so. Yeah, it's before that. Hang on. Ooh! It's probably this, isn't it? This pot right here. Yeah, because we don't have a return value. Okay, yeah. So we need to change that now. Because we don't expect a return. So what we have to do is we have to actually look here. So if the function is like this, right? Hey, we have to look at the function that we're calling, so we can actually just look here. So if function arrow type does not equal type void, then gen pop. We can just do this on one line even. Not a big deal, right? And that should be pretty good. And go here, run that, and we still stack underflow. Why do we do that? Chasm and still pop. Because I set it to int. Yeah, so let's make it a void. There we go. Okay, so now we don't actually do that, and now it is valid. Yeah. Let's have the return 0 there, and that's gonna give us an error, so let's make this int. And okay, so it doesn't work when we do that, you see? That does not work, but it doesn't underflow, you know? So we do generate the pop here, and it works fine. Why does this not work fine, right? Why doesn't that work? Passing, that works. So why do we need another pop when we do that? Call print in. Pop out. All right, maybe I should step through the stack. You know. So we go here and we have a value on the top of the stack. So we have an integer, right? We do the integer, push 9, compare, and then yeah. So we're gonna say it's 1, so it's true, right? And then we don't jump to a 1 because it's not 0. And that actually consumes that. So we do that again. Push 10, divide, and then you indupe the value, and then you call this again, right? So we have all these values on the stack. So you call this, and now we go here. So we have the value here that we changed. Duplicate the value, push 9, compare them, and then it's less. So we jump over, right? Jump over it. Push the string, which has the stir when and the stir. And then we do all this to index and stuff, and you end up just with the extra stir on top. And let's see, indupe 3. So 0, 1, 2, 3. So that is the value here. That's not right. That's the value. So I'm just saying it's 10. Right. 10. And you do all this, which ends up with just a single value. So in this case, it would be 0, you know? So where was it? Expert, yes, that's this one. It's the, like, character value of 0. So it's going to be 48, actually. And then we push 1 and write. What are we writing to? We're writing it to the string. So we push 1. That is the amount to write. So we wrote it to this string here. Okay. And then we actually write it. So we undo the string, push 1, native 1. So we duplicate the string. Push 1 second, so both of these. And then pop off this. But we don't pop off the extra one here. Why do we have the pop there, though? Anyway, because we undo 0, push 1, native 1, and that consumes both of those. So why do we have that extra pop? What's that for? Yeah, that's for if it's a string literal, but this is not a string literal. Right. Because that means to pop off the length. So we need a way to detect that. So we need actually an extra pop here. That's actually what's throwing it off. That is what breaks the whole thing, I believe. Yeah, because then we have that on the stack handle. So I put the pop there, and we pop off the... Well, actually, we can make sure that's the length, right? We can dupe. Well, yeah, let's just print it actually. Let's look at that. 2. That is the length of the string, right? Yeah, because it includes the null termination tag. So, yeah, but that messes up the index. Okay, so what? But we don't really want to pop that there, actually. If I just get rid of that pop, get rid of both of them, then what does it look like? Let's see. Four, 4, 4. Okay, that makes it even worse. Yeah. Dang, this gets confusing because like we had the native right. We generated the pop to get rid of the thing from when we were pushing the string, which pushes both of the values. But for this, that doesn't exactly work. Yeah, so I'm not sure. Why do we do this with the... Oh yeah, because that consumes both of them, the native. Right. Okay, so that I'm pretty sure is what is throwing everything off. But no, why does that get fixed then if we don't return? Yes, maybe it's not that. It's a bit confused. But yeah, we didn't implement void, so that's cool. I'm gonna create an issue for that, and then I will come back to it. Let's see. So issue, what's that issue with either right, or with calling unwanted data. Okay. Needs probing, right? So I will look into it. Okay. This works though, and this is a better example now, so I'm gonna copy that into the examples and just replace the one I think already. So let's see. Print and can. Okay, so what would be better here? What if we could alloc, right? We could do alloc. Well, actually, we could do string stir equals alloc, and then some value, so alloc, so the size, so it'd be 2, right, in this case. And you can also do, eventually size that character times 2 or whatever you want it to be pedantic, rather, right? But something like that, instead of this. And it basically is the same thing. Well, do you even need a 2? Actually, it won't work without the 2. Unless we modify right where you pass the size as well, which is probably a good idea anyway. Like, because right really takes 3 things. It takes the file descriptor, right? And even in the native right? It takes the file descriptor and then the size of it. But for the way that we're handling it, we just get the size by using Sterling. But maybe that's not even ideal. Maybe we'd rather pass it, So I'll have to think about that. But yeah, basically we have to alloc 2 because we need the null termination character. And then we could set that and then also string 1 equals that, We could set. But it actually gets 0 initialized by, it gets 0 initialized by default. So we could just do 2 and then set the value. Right. But this would be a native call. And that means we'd have to turn it into an expression, you know? So we need to support native calls in expressions. And not all of them return values. So it's an interesting thing. I'm not sure I'm going to do that just yet, though. Because I'd also like to be able to return a pointer, you know? So maybe just a void pointer would just be called pointer. And then we can implement other stuff like we have pointers and stuff. But like a void pointer, right? We could return that. And that could be like a generic way to return any kind of pointer you want from a function. Like right now we can return a string, right? I'm not going to actually modify this one because that's not a very good idea. Yeah, so I'm going to modify some of these examples. So Kano. Yeah, let's modify this one. So yeah, you could return a string. So let's make foo with nothing, stir. And it's just going to return a string, right? And we'll add a new line here. And then we'll do right foo. Be sure we can just do that. And if we need to modify run.sh and make this, it's not called foo, it's Kano. Run that and expected string. What the heck? It's because of this. Stir equals foo. Because this works. I was actually testing it. Yeah. Okay, so you can't do that. Why did that not work? That is interesting. I'll need to look at that. Hang on. So expected string. And that's in column name. Okay. Expected string. Did I do that here? Right here. Okay. Oh, shoot. That could be a function call. And not equal expr func call. Func call. Or maybe it's just called func, actually. Hang on. Rebuild that. Maybe just func call. What's it called? Expert type. Let's see. Func call. Okay. Okay. I'm kind of inconsistent when I name stuff. I need to fix that. Func call like that. Okay. It's 1C. One call. Okay. I'm gonna go here and I run that. Stack underflow. That's interesting. Okay. So why does it stack underflow? So what? Oh shoot, is it? No. So what is it this that's underflow? Yeah, the right issue. Could that be it? No. Oh shoot, yeah. I didn't actually rebuild it properly. Okay. Yeah. Okay, so that's what it is. Because again, this expects that. But when we had the string, we also would want it to return the capacity of it, because we have that stored on the stack. So we need to modify that as well. And then, you know, this would not fail. You know, the thing is, I have it push the capacity, but do I even want that? And would I rather just track the capacity in the compiler, you know? And manually keep track of it, if that makes any sense. Because obviously I'd like to eventually have, you know, like the length of the string without using no termination. Like size strings, basically, is what I'm saying. Okay, yeah, because that's what's causing that. Otherwise, this works, as you can see. So that's cool, but so I need to, we have the return. If it's a string, for grabbing a string, right? So we set it up here in an expert. We inswap file with that. Yeah. You know, that makes it really annoying, you know? So if it's an array or a string, which is technically just a type of array, let's add a to do here. So do array and stored capacity. What? Oh yeah, because I don't know I want to do that. I just want to kind of go through and see what I need to fix, right? So another thing, I was just thinking of it, but I don't remember now. Hang on. get the function. Check that. Alright, yeah, and same thing when you return arrays. You know, so if you return an 8, we'll even do that. I don't know if that even works. Yeah, okay. So that could be the advantage of returning a pointer, is you could just return any of those, and then it would be basically cast. So we need a way to cast as well. And I feel like I want to do it in the C way, you know? Where we go like this, and we just cast, you know, the pointer or whatever. So you could cast it to a stir, and that would be valid, you know? Because that is a pointer. But then you don't get the size as well, obviously. So yeah, we do need a way to return arrays. So I'm gonna create an issue for that. I would like to create issues for a lot of things. So return an array from i.e. 2 int 3. Okay, these are for Kano script, but I think can be figured out, right? Okay. So that is stuff. What else? What else do we need to do? So eventually I need to implement the preprocessor, right? The one that we use for the assembly. I think that would be sufficient for this. In the future, maybe a different way, like import multiple files. Then we can import, you know, standard.kano, and then use that. It would basically just expand here. I need to update the lecture to get that to work, but then, you know, we can include stuff, and that would be pretty cool to have. So what else is here? So examples, yeah, I think I'll remove the I want people to be able to see what's going on here. So I think actually I found the test.kano. So what is this? String compare, same. Let's get rid of that. So let me modify my message and change it to test. I type array, but find char. It's not Kano. Oh shoot, because they're not the same type, are they? Okay, yeah. So that's something to do with the type checking, especially in the front end. So I need to make that a lot better. You just check if they're not the same. But let's do and that, and type left does not equal extra array, and type right does not equal extra array. Right, so if either of them are an array, then we will not throw back error, you know, or a func call as well. Because those are kind of more ambiguous, and we need to do more advanced stuff to get those to extra. Let me make a new line for this again. Their fun call and type right does not equal third fun call. Alright, let's take a look at that. Okay, so why does it print out all this stuff here? Why did it print that out? What? Let's see, do we have a print that? It's gonna be in the back end, I think. Something that's not at print, you know? We do. Okay. Yeah, for the array. So I need to get rid of that. There we go, that's better. So test.kano. So if a, well, alright, we just need the exit. So echo that and okay, so they are the same. And if I change this to be not the same, then that and it's 0. Okay, so that looks like it still works. So let's do that, and let's rename it. So let's move test.kano to stir compare.kano. So let's watch some good examples, you know, and we'll copy and paste stir compare to examples. And maybe I could even implement stirlen as well, because that's basically the same thing. Just do while it is not really the same thing, but basically we can do stirlen, right? And just need a single stir, and yeah, it returns void. So this could return void as well. No, it needs to return. I have a stupid. Okay. And this cannot return void. This returns the len. Yeah, not thinking at all. Okay, so we want to just do len int equals 0, and then wall stir len Let's do I. I does not equal that. Well, A. That then, and let's do I equals I plus 1. And yeah, we need to return I at the end. Okay, stir len x. So let's try that out. Let's modify the organization actually to use stir count. Echo that and stir count what? Stir count dot kano. Stir len. Stir len x. Maybe I'll move this into its own thing, you know? So make stir len dot kano. And then I will grab the stir compare. That's not right. Stir compare freaking balls. Dot kano. There we go. I'll just grab this, you know? Grab it, and I'll move it to the stir len. Where's stir len? Stir len. There we go. And we'll space it in there. And I'll save that, and I will change the stir compare back. So I'll get rid of the, that's not the right one. Stir compare, there we go. Get rid of this. And I'll change this back to stir compare. X and Y. I want to make sure that still works actually, so that, and perfect, that works. Stir len, not kano. So then we just need to call this. So x int equals stir len of, we can't use string literal, because that doesn't work right now. Which, yeah, so stir len of, supposed to be there. And then we'll exit with x. Shoot, something is broken. What the heck? That's not good. I don't know why that happened. Yeah, I've been having some issues. Like, I wasn't having issues for a long time, and then just started having issues. So with x equals y. We'll declare y after. So y stir equals string, right? String. Yeah, so why is it 1? No, because that's not right. Well, that's H, so we need to make this stir len. And it's 6. Okay, that might actually be right. That's not what I meant to do. Stir len dot kano. So let's see. 1, 2, 3, 4, 5, 6. That's right. Let's make it. This string is x cars long. Okay. I don't know how many that is, but I'll just try to print that out. Or write that. Okay. And we can use the print int to actually write it now. So that's the thing as well. If we want to do that. I'm not going to yet. Let me say, I'm going to assume that that's right. So I will copy and paste stir len kano to the examples as well. So, you know, I just want to build up some examples. You know what I'm saying? Okay. Alright, so I think I will commit this. Let's see. Add few more examples and implement void type. Now, something else. We can use the void type in variables, and it's just going to let you give a value. So again, that's going to be when we implement further type checking. Push that. Okay. Yeah, so that's probably going to be about the end of the video. So thank you guys for watching, and I'll see you next time. Bye.